Hello, students, scholars. This video is going to help you understand proportional relationships with graphs. So the first thing I want to point out is our anchor chart. So in a graph, a proportional relationship should have two characteristics. The first characteristic is it should form a straight line. Now, in order for a graph to represent a proportional relationship, it needs a straight line. Why a straight line? When you have a constant unit rate, it would form a straight line when you graph it. Okay? So the first characteristic is you need a straight line. And if all of the ordered pairs, X and Y pairs, have the same unit rate, it has a constant of proportionality, and on a graph, it would form a straight line. Now, the second characteristic is that it must pass through the origin. The origin has an ordered pair of 0, 0. So on this graph, this would be the origin, 0, 0. If the line, the straight line, passes through 0, 0, that makes it proportional. Okay, so those are the two characteristics of a proportional relationship. So what's going to happen now is we're going to take this problem using a table, and we're going to graph the table on to the coordinate plane or quadrant 1. So we're going to take the table, graph it, answer the questions, and then we're going to elaborate and look at the graph and see what we can come up with. So the first problem that we have, it says Alonzo pays $44 plus a percentage of his sales to participate in the craft fair. The table shows the amount Alonzo pays in relationship to his sales. So what we're going to do is part A says we have to graph the relationship. So what we're going to do is we're going to graph it. So we're going to take the X coordinates and the Y coordinates, and we're going to graph them. Now, we only technically need to graph 2 points. And the reason why we only have to graph 2 points is in order to make a straight line, you only need 2 points. Okay? So we don't necessarily know if this table represents a proportional relationship. So what we can do is we can determine before we graph it if this table represents a proportional relationship. So what we can do is we can go back to our anchor chart, find out how we determine K if each of the ordered pairs has a constant of proportionality or constant unit rate. We would take Y and divide it by X. So if we take the first pair and we take $4.50 and divide it by 10, that would give us 45 cents. If we were to take $5 divided by 20, that would give us 25 cents. If we were to take $5.75 divided by 35, that would give us some long decimal, but we're going to round it to 16 cents. If we were to take $6.25 divided by 45, it would give us about let's double check that. $6.25 divided by 45 is about 14 cents. $6.50 divided by 50 will give us 13 cents. So none of these are the same. They're not all the same, which means this would not represent a proportional relationship. So being that we know that, let's graph. So we only want to graph two of the points that actually make sense and that we actually can graph. So what I mean is, I don't want to graph decimals. I want to get more or less whole numbers, integers, maybe halves. Okay, so we're going to pick two of the ordered pairs here that would be simple to graph. So I think we should take the obvious, which is 1, and the other obvious, which would be, we actually have 3. So we'll do 3. We only need 2, but we'll do 3. So we're going to have an x value of 10, y value of 4.5. X value of 10, so that makes here 10 and 4.5, which would be in between 4 and 5. So it would be about here. So let's plot that. So now we have a y value of 5, x value of 20, or x value of 20 and 5. So now we're going to go 20, 5. Now, if you guys don't have a touch screen device, you can create a text box, which is fine. So the third value is an x value of 50 and a y value of $6.50, which would be in between 6 and 7. So we have 50. Gonna go up in between 6 and 7, which would be here. Now, part A done. Part B, we're actually going to come back to that. My question is, does this, so far, if I was to connect these points, does that make a straight line? Some people would say yes. Remember, we need two characteristics. It must make a straight line and it must pass through the origin. So if it's only one out of the two, it's not proportional. It has to represent both characteristics. So this somewhat looks like a straight line. We can say yes just for purposes of the problem. But does it pass through the origin? So the question would be no. And if you notice, where does the line start from? The line starts from 0 and 4. So if I go back to the problem, it says Alonzo pays a fee of $4 plus a percentage of his sales to participate in the crafts fair. So 0 and 4, what does 0.04 represent? This represents the fee that you have to start out with, or that Alonzo starts out with. So before he does anything, he has to pay a $4 fee. That is his starting point. Now, if I go back to characteristics, if it passes through the origin, that means the starting point is 0. In this problem, the line starts at 4, which means that is the starting point. In order for it to be proportional, it has to have a starting point of 0. This is what we would call non-proportional because it does not start from the origin. So what does 0.04 represent? 0.04 represents, and I'm referring to the problem, the $4 fee. Okay, the $4 fee, which is the starting point. Another name for starting point is the y-intercept, but we're going to leave it at starting point, just so you know. So that is the starting point. C is the ratio of y divided by x constant. We already calculated that, so we would say no, it is not constant. Why is it not constant? So that's number one. Number two, there's no constant unit rate and doesn't have a starting point at zero. Put at zero. So your work up here constitutes and justifies your answer. Is the relationship between the total fees and the amount of sales a proportional relationship? No, we already explained this. No. Doesn't have a constant rate. That's it. If it doesn't have a constant rate, that means it cannot be proportional. Now, to add on to that, no, it doesn't have a constant rate. It also does not start from zero. Okay? So that's how you would determine if a table, if you graphed it, represents a proportional relationship. Now, in this example, we're going to actually take a graph and we're going to place it, the information from the graph, and create a table. So the first thing I want you to understand is that this graph has a title. It's called spices. Now, our two units that we're using, chili powder in teaspoons, cumin in teaspoons, those are our two variables. Now, always the horizontal axis is always X. The vertical axis is always Y. Horizontal X, vertical Y. So we want to label X and Y appropriately and accordingly. So when we actually do that, our X is going to be cumin. Our Y is going to be chili powder. So X, cumin, Y, we'll just put chili. So that's how you would label X and Y. Now what we're going to do is we're going to plot the ordered pairs, and we have actually 4 ordered pairs here. Actually 5. 1, 2, 3, 4, 5. Sorry, 6. We have 6 ordered pairs. So the first ordered pair, if you notice, there's a point, is 0, 0. So I'm going to plot that. 0, 0. So it's on the graph. It's on the table. Our next ordered pair is 1, 4. And just as a review, just know that when you have ordered pairs, the first number is X, or the X coordinate. The second number is the Y coordinate. Next we have 2 and 5/10, so 2 and 1/2. 10, we have 4, 16, 4 1/2, 18, 5, and 20. Now, just by looking at this graph, does this graph represent a proportional relationship? Give you about 10-15 seconds to look at it. Does this graph represent a proportional relationship? And the answer would be yes. It forms a straight line. It passes through the origin. Now, all we did was we took all of the values, the coordinates from the graph, and we created a table. So now what we want to do is we want to determine two things. One, what is K? Two, write an equation using K. All right. So how do we find K? We find K by taking Y, dividing it by X. Now, in this case, when you have a table with 0, 0, you do not use 0, 0 as one of your testers or one of your pairs to find the unit rate. You don't want to use 0, 0 to find K. You leave that completely alone. So we're not using that. What we are going to do is we're going to take 4 divided by 1. Gives us 4. 10 divided by 2.5. 4. 16 divided by 4. 4. 18 divided by 4.5. 4. 20 divided by 4. So that is K, or our constant of proportionality, our unit rate. Now we want to write an equation. So if we wanted to write an equation, our equation again is Y equals K multiplied by X, or KX. Now we went over this previously in regards to writing an equation. When you have Y equals KX, you are not doing anything with X and Y. You are just replacing K. So if we replace K, our K in this case is 4. Our equation would be Y would be equal to 4X. That means 4 multiplied by X would give you Y. 4 multiplied by 1 would give you 4. 4 multiplied by 1 would give you 4. True. 2.5 multiplied by 4 would give you 10. True. 4 multiplied by 4 would give you 16. True. 4.5 multiplied by 4 would give you 18. True. 5 multiplied by 4 would give you 20. True. So this would be our equation. Y equals 4X. So remember, all we're doing is replacing K. So we took values from our graph, made a table, found K, wrote an equation. Now, the last thing I want to cover is when you have a graph, you can actually find the unit rate from the graph. So in your unit summary, it states that in a graph, when X is 1, when X has a value of 1, the Y value is your unit rate. So in this graph, we have 1, 4. 1, 4 is our ordered pair that we're focusing on. Now, when X, now remember, I erased it, but I'm going to write it again. In an ordered pair, the first coordinate is X. The second coordinate is Y. When you have X being 1, or X has a value of 1, whatever the Y coordinate is going to be your unit rate. So this number here is going to be your unit rate. Now, if you look at our ordered pair here, 1 or X has a value of 1. So our unit rate is 4. Now, what does this mean in context to the table? If we wanted to say it or write it as a rate, remember, y divided by x means y per x. What does y represent? Chili powder. What does x represent? Cumin. So, in context, based on the graph, based on what we know about rates and unit rates, y per x. So it's going to be chili powder per cumin, which if we were to write it, so in context, it would be 4 teaspoons of chili powder per 1 teaspoon of cumin. This would be our rate. That's how we would describe our rate. In this case, our unit rate. And remember, we are using the word per. It's y per x. So we labeled x and y for a reason, so that when we have to write our rate, we already know what x represents. We already know what y represents.